Hi guys, I was certain that I'd scheduled this one and it turns out I haven't. Now, if you're watching this one recorded, which a lot of you will be, then go ahead and check out in the description. I've put a playlist with all of these daily revisions in. So if you're looking at this and thinking, well, what's this feedback all about? Then you need to look back at the previous question and look at some of the answers that people have been given for these daily physics revision questions, because they are excellent. Some of them are really, really good, and I've gone and I've done some comments on people's responses and given them some feedback there. But I'm going to do some feedback on yesterday's revision question, and I'm going to introduce one more daily revision question today, and then I'll be back with some feedback on it tomorrow. So as I said, welcome to Gorilla Physics. Make sure that you are subscribed so you see these live feeds, you know, these are all about applying your knowledge, which people are doing really, really, really well. I was just chatting to Lane, and we both agree that the GCSE responses are really, really strong, and you guys are working so hard, and you obviously deserve those grade 9s, and that's what we're all about, getting that grade 9 or that A star. So these questions I'm cooking up are quite tricky, and I make no apologies for that, because it's all about applying your knowledge to difficult situations. So here's another one. So a bike tyre. This is the next question. When a bike tyre is inflated using a hand pump, work is done on the gas. Explain why this leads to an increase in temperature. Also, use kinetic theory to explain why the tyre is harder to depress when at a higher temperature. Then the bonus ideas, the other ideas are both pressure and volume increase. Explain why this is not a contradiction of Boyle's law. So that's a really difficult idea, I think, but Boyle's law is definitely in GCSE and A-level. So have a little think about that. Both the pressure and the volume increase when you pump up a bike tyre. Explain why this is not a contradiction of Boyle's law. Then there's an A-level idea. So this is just an A-level idea, but feel free to have a go if you're GCSE. From first principles, derive an equation which shows that temperature is proportional to average kinetic energy. So that is a biggie, and that's one of the ones that people find really hard. I will have a look in the chat in just a little while, so stick around to the end if you're asking a question, and I will also read that question one more time, but that is in the description, as is the playlist, so you can go back through all the old ones and have a little go at the questions yourself and already see my kind of feedback and what I was kind of getting at there as well. Cool, right, let's come back to your chat about the helium nuclei in a little while. Some really good ones. Now that last time, how do crumple zones work basically is a really typical kind of 3-mark question. It's applying Newton's laws. I was really impressed by the way you were applying Newton's laws. It is definitely an application of Newton's second law, which all of you got. So whenever they ask about safety features and reducing collision force and stopping injuries, then you need to bang down these same points. You increase the collision time, so you decrease the rate of change of momentum. You need to get that rate of change of momentum, so you decrease the force. So that is why longer time leads to less force. You can explain that in terms of a longer time is a lower acceleration. So Newton's second law basically is F equals ma. Should really be the sum of the forces, a resultant force. And the tricky question about Newton's second law will be about the resultant force is equal to mass times acceleration. But acceleration is a change in velocity over time. So we can insert that into this equation. And the GCSE kids as well were doing this really, really well and derive this next expression of Newton's second law, which is a force is a rate of change of momentum over time. So I often write F equals delta P over T, and that's my definition that I remember for Newton's law, second law. There is one more way to memorize that as well, which is impulse. So impulse is a delta P, it's a change in momentum. And actually, at A-level, I would encourage you to memorize it in this kind of state. Ft equals mv, or Ft equals delta P, and use the term impulse. I don't think there was a lot of that. There was a lot of chat about inertia and having to slow the car down from what it was doing. That requires a force. That force is a result of a force on the car, means that they have to do a force on the wall. There's an equal and opposite force by Newton's third law, but really this was about Newton's second law. Great, you all applied that. Lane's response was excellent, especially the significant figures, Lane, fantastic. Also some interesting ideas in there about plastic deformation and absorbing energy, and that's a basic idea of crumple zones and crash helmets is absorbing energy, but we like to talk about the forces because force is what actually makes something happen. Rachel's response had a great bit of context, really good bit of history, context, and really strong derivations, especially for somebody at a GCSE level. A great application of Newton's 1 and 2 there, Rachel, as well. Fantastic. A-level students have said, talk about impulse when you're talking about it. Impulse just means a change in momentum, so it equals force times time. So a car without crumple zones essentially has the same impulse as a car with a crumple zone, but the car without the crumple zone has a smaller time, so that you must have a bigger F to equal the same change in momentum, and that's bad news for passengers. All right, that's that chat there. Today's question, and for tomorrow, similar sort of time tomorrow, when a bike tyre is inflated using a hand pump, work is done on a gas. Explain why this leads to an increase in temperature. Use kinetic theory to explain why the tyre is harder to depress at a higher pressure. That's the two main questions to take, or the two main parts of the question. And then the bonus ideas are both the pressure and the volume increase, and explain why this is not a contradiction of Boyle's law. And then the A-level idea, from first principles, derive an equation that shows that temperature is proportional to the average kinetic energy of the particles. All right, biggie. Okay, so let's have a little look at this chat that's going on down here. Yeah, we're back in the old classroom. Somebody was just using this classroom. This is not really my classroom. My classroom is less tidy than this. So I picked this one because it's got decent enough 4G signal and it's a bit more tidy than my classroom. Right. Do we need loads of energy for particle interaction? Why do we need loads of energy for particle interaction? I'm not sure what you mean by that. Are you talking about, you're talking about collisions and things in the Large Hadron Collider, etc. Well, what's happening in the Large Hadron Collider is we're taking big particles and we're smashing them together at high energies. And we want to see what comes out. And we're interested now in the most massive particles. We're interested in the higher energies of the universe. You know, we're interested in explaining really what the universe was like very, very shortly after the Big Bang, and we're talking 10 to the minus 30 kind of seconds after the Big Bang. We want to know about that tiny little bit of time. So we're trying to recreate the really high energy interactions. Now, energy can be converted into mass by E equals mc squared, and mass can be converted into energy. So if we want to get large particles, large massive particles made, like the third generation of matter in the Standard Model, then we need really high energies to convert to high masses. I hope that, maybe that's what you're talking about. I think I recognize that kind of question, which is why do you need a lot of energy in particle collisions? Does that answer your question, Addy Daddy? Why is a large and stable nucleus more likely to decay to helium-4 than helium-3? So because helium-4 is the most kind of stable arrangement of neutrons and protons. So really a nucleus is actually a group of alpha particles, is one way to talk about it. So even if you're GCSE, you'll be familiar with what an alpha particle is, which is a helium nucleus. And it just so happens that the arrangement of 2 protons and 2 neutrons is very, very stable as a nucleus. It's a kind of funny spike on that binding energy curve that you're probably familiar with from your A-level. You wouldn't know about that for GCSE. So loads of energy is made when hydrogen fuses into helium-4 more than helium-3. It will make helium-3 like as a reaction, but it's most likely to do the most stable, or it's going to end up as the most stable setup, basically. I think nuclear physics is absolutely fascinating, and there's some of the FET sims are really, really good for showing you that idea of the nucleus being just kind of really a bunch of alpha particles, because they're really stable kind of arrangements of those particles, and they are kind of, you know, tussling with the other kind of alpha particles in the bigger nucleus. The nucleus is not this kind of, you know, still image that you used to see in the book. It's this massively more, you know, this loads of energies, loads of repulsion and attraction from the electromagnetic force pushing out, strong nuclear force pulling in. Really exciting things going on, like exciting as in lots of energy. And Ali Daddy's got it. It's because helium-4 is more stable. Yeah. Also, the isotope technetium-99 has a half-life of 6 hours and decays by emitting gamma. Isotope thallium-2001 is another use in medical applications. Thallium has a half-life of just over 3 days. Not sure what your question is there. Is that the next bit? assess the suitability of these two isotopes for use in hospitals to produce an image of the inside of the patient. So I think that they're getting at traces. 6 hours versus 3 days. So if you were to inject, yeah, technetium is a isotope that's used for tracers in medicine, and this is in GCSE and A-level. It's good because gamma, so it leaves the body. It's good because gamma doesn't do much ionization when it's in the body, and it's decayed by half after 6 hours. So after 12 hours, a quarter, after 18 hours, an eighth, and so on and so forth. So within like 24, 48 hours, you're no longer radioactive, or very, 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 very small amounts of radiation being given out. So that's why it's better than 3 days. Think about being, being exposed to gamma radiation for high levels for 3 days is quite a lot, isn't it? And even if it's down to about a quarter after 6 days, or an eighth after 9 days, then so right, yeah, 3 days, yeah, then there's still quite a long dose of radiation. So time is one of the contributing factors to the dose of radiation that you get. Does that make sense, Lane? Are you planning to cover most of the syllabus areas for these questions before the exam? Yes, although I haven't got a spreadsheet and I'm not working through them very systematically, but I will try my best to cover most of the areas. If there's an area you think you haven't covered this much yet, Kit, then just mention it and I'll write a question for them. Is that all right? So you need a lot of kinetic energy to create more mass particles of the kinetic energy transfer energy. Yeah, exactly that, Addy Daddy. You need a lot of kinetic energy in the particles to create more massive particles as the kinetic energy, which is excess, is transferred into mass. Yeah, perfect. Lewis Matheson, legend, said that National Grid was badly answered last July OCR. Is there a tough question that they can ask on this beyond describing it? Yeah, the things that people didn't get well was the heat loss by I²R power. So hopefully you know the equation for electrical power, which is current times voltage, but you can also make I²R, yeah, by substituting in Ohm's law. So if I put Ohm's law in there instead of V, so I get I times IR, I get I²R. And this equation for GCSE, remember this is power loss equals. Now, the point is that we reduce the current in the national grid by using step-up transformers so that we get less power loss, so that they're more efficient. So yeah, it wasn't answered very well because people weren't talking about the lower current leads to less heating in the wires, then less waste energy. What people tend to say about the national grid, which is just completely wrong, is they tend to say high voltage, so the electricity gets there faster. No, don't say that. It doesn't get there. It's not about speed, okay? It's not about speed of transition of the electricity. It's a high voltage so that you get a low current, so that you get less power loss due to the wires heating up. And that's that model of a current in a wire, electrons bashing along, hitting into the atoms and the ions, the metal ions in the lattice, causing lattice vibrations. We were talking about it in one of our daily physics things. So look at the link in the description for this playlist and go through them. And that we talked quite a lot about that idea of current causes heating. It's a big idea in GCSE physics, and it's an important idea in all physics. So remember that equation. Power loss equals I²R, which means if you halve the current, you quarter the power loss. So that's the reason why we have step-up transformers in the national grid. Right, what's next? Aha, there's loads, yep, so that's good. So the hard questions are always going to be on that type of idea, I think, Rachel, if that's okay. Also, yeah, the working out with the transformers, using the transformer power equation to actually work out things. Lane's got it now, that's great. Also, why is a seatbelt a good safety feature in a car? Is it because of elasticity? It's the same reason. So seatbelt means that rather than hitting the windscreen and coming to a stop in a really short time, so a very high force because of Newton's second law, yeah, rather than coming to a stop in a really short time, the seatbelt slows you down over a longer period of time, so a lower rate of change of momentum, so a lower force, so less damage. So seatbelts the exact same reason, and as our airbags, okay, the exact same reason is increase the time for less force. Curry says thanks. Thank you, Curry. How many hours minimum should I do for A-level physics, considering my A2 exam? Look. At this point, you do as much. Curry, answer in the real comments if that's all right, so I can see them and respond to them, and you'll get pinged when I respond to them. Yeah, do as much time as you feel comfortable at the minute, mate. I mean, yeah, it's in 3 weeks. Okay, so you've got to think to yourself, I want to get to that exam feeling like I've covered all the bits that I find the hardest. Okay, not what other people find the hardest or anything like that. Not cover the whole thing again in 3 weeks, because you won't have time to do that. But get there knowing that you've done a good solid amount of work. So as long as you do that, then any amount of time is fine, really, isn't it? Get your rest as well. I felt like having a go at one of my A-level physicists. I don't know if they're watching, because they decided it was a good idea to go to see some stupid comic book film. I don't know if there's any fans out there last night when it got released at 12 midnight, but I'm only joking. But you know, if that's okay, if that's what relaxes you, that's important to you, then do it as well. But really, you do the amount that's comfortable for you, the amount that you know you're going to be pleased with, the amount that you know you've fit in a solid effort, and that you can be proud of your result, and just do your best. But think now, well, how much do I need to cover? How many weak areas do I have? And try and knock them off early. And then if you've knocked off 4 weak areas in a couple of nights, then, or in a week or something, then you can think to yourself, right, great, well, I'm working an appropriate amount. But if you've got 4 weak areas and you only manage 1 in a week, then you need to work a little bit harder to get them all knocked off by the exam. Does that make sense? I hope that makes sense. All right then, my dudes. Yeah, that's it. Aiming for 999s in science. Joshua, that's amazing. Now, I didn't mention yours, but that was a really solid answer, Joshua, as well. So great to see you. Have a go at this one. Leave off the derivation if you're a GCSE, unless you're really keen. There's been some absolutely solid answers from your GCSE folks as well. Really applying Newton's laws is it's not one of the tricky parts, it's actually one of the easiest parts. You need to realise, oh, this is a Newton's laws question, and you need to just pull that out of the bag and apply that to that situation. I've got a really good Newton's laws summary, which applies for both GCSE and A-level. If you just Google that one up, I'm sure you'll find it. Gorilla Physics GCSE, Gorilla Physics, Newton's laws summary. I'm sure you'll find the video. Right, okay then. Any last questions for this feed? And then this is the question for feedback tomorrow. So when a bike tyre is inflated using a hand pump, work is done on the gas. Explain why this leads to an increase in temperature. Use kinetic theory to explain why the tyre is harder to depress when at a higher pressure. And then the bonus ideas, both the pressure and the volume increase. Explain why this is not a contradiction of Boyle's law. And the A-level idea, from first principles, derive an equation that shows that temperature is proportional to the average kinetic energy of the particles, which is a which is a clue for the first part of the question. All right then, my dudes. I don't think there's. I have some from this past paper I just solved. Not sure what your question is there, Lane, but ping it in the comments if you've got any questions. My name's Kit Best Masters. Make sure you're subscribed, and I will see you tomorrow for the feedback